At this moment, an incredible wave of excitement is sweeping across China. After 6 long years of relentless exploration, Chinese geologists have made a breakthrough that could change the nation's energy future. The discovery of a super oil field buried deep beneath the desert sands. Early estimates put its total value at nearly 600 billion US dollars, with over 1 billion tons of oil and gas reserves, making it one of the largest fields under development anywhere in the world. To put that into perspective, that's enough oil to power all of China for about 2 to 3 years straight, or enough to keep every car, plane, and factory in the country running without importing a single drop. The scale of this discovery is staggering. The exploration zone alone covers more than 17,000 square kilometers, an area so vast it's about 14 times larger than the entire city of Los Angeles. But there's a twist. This treasure isn't sitting close to the surface. It's buried several kilometers underground, beneath one of the harshest deserts on Earth. Extracting it won't be easy. The oil layers are incredibly thin, some only 0.6 meters thick, and they lie as deep as 10,000 meters below ground, almost as deep as an upside-down Mount Everest. So the question now isn't just how much oil China has found, but how on earth can engineers possibly bring it up? And beyond that, what does this billion-ton discovery mean for China's energy independence and its place in the global oil game? Let's dive deeper into the story behind this monumental find, starting with the mysterious desert that hides it. To truly understand this discovery, we have to travel to a place that almost feels like another planet, the Taklamakan Desert, located in China's Xinjiang region. It's a vast sea of golden dunes stretching roughly 1,000 kilometers from east to west and 400 kilometers from north to south. Covering about 330,000 square kilometers, it's nearly the same size as the entire nation of Germany. The Taklamakan is no ordinary desert. It's the second largest shifting sand desert in the world, where winds constantly reshape the landscape. Temperatures can swing from over 50 degrees Celsius during the day to freezing cold at night. The sandstorms are so fierce that they can bury vehicles, equipment, and even small villages in a matter of hours. Locals have a saying, "If you go into the Taklamakan, you might never come out." But beneath this lifeless expanse lies something extraordinary, a hidden world of energy. Few people realize that under these endless dunes rests one of the most resource-rich regions in all of Asia. China's story here began as far back as the 1950s, when the country was still struggling to build its economy and had to rely heavily on imported oil. Back then, Chinese scientists and engineers had almost no advanced tools, no satellites, no modern drilling technology. Yet, driven by determination, generations of geologists ventured into this desert armed with little more than maps, compasses, and courage. They endured extreme heat, dust storms, and isolation, spending months living in tents, often cut off from the outside world. Many fell ill from the harsh conditions, but they kept going because they believed in one mission: to find oil that truly belonged to China. For decades, they found little success. The desert seemed stubborn, offering nothing but sand and silence. But their persistence slowly paid off. Deep beneath this barren land, they began detecting signals, clues of buried oil and gas deposits that would one day make history. What started as a desperate search in one of the world's most unforgiving places would eventually transform this desert from a dead zone into one of China's greatest energy frontiers. And that transformation began in the late 20th century, when everything changed. By the late 1980s, after decades of relentless exploration, China's persistence finally paid off. Between 1989 and 1992, geologists struck success, discovering a series of oil and gas fields beneath the Taklamakan Desert. It was a turning point in Chinese energy history. What was once called the Sea of Death suddenly became a land of hope and opportunity. In just the past decade alone, China uncovered 17 major oil fields, each containing over 100 million tons of reserves, along with 21 large natural gas fields, each holding more than 100 billion cubic meters of gas. Together, these discoveries have revealed an estimated 8.6 billion tons of oil and 2.5 trillion cubic meters of proven gas reserves. These are not just numbers. They represent the birth of an entire energy hub that powers millions of Chinese homes and industries today. This transformation of a lifeless desert into a thriving oil region has given China a sense of pride and energy independence that once seemed impossible. But even with these successes, one discovery would soon stand out as the crown jewel: the Fumen oil field, a geological marvel that defied all expectations. Located deep beneath the desert, the Fumen field contains over 1 billion tons of oil and gas, making it one of China's largest and most challenging energy projects ever. It spans an area of 17,000 square kilometers, roughly the size of several major global cities combined. To put its scale in perspective, it's smaller than Saudi Arabia's legendary Ghawar field, which holds over 11 billion tons. But for China, Fumen represents something far more symbolic: a victory of human will and technology over nature's limits. However, success here didn't come easily. The oil isn't resting in shallow pockets like in the Middle East. It's buried deep, nearly 7,000 to 10,000 meters underground, trapped in complex rock formations created hundreds of millions of years ago. In fact, finding and extracting this oil is as difficult as trying to reach for a fruit hanging below an invisible mountain, an underground Mount Everest made of rock and pressure. So how did Chinese engineers manage to locate and extract oil buried deeper than any other place in Asia? That's where China's next chapter of technological brilliance begins. Imagine standing at sea level and trying to touch the peak of Mount Everest, but upside down. That's how deep China's engineers had to drill to reach the oil hidden beneath the Taklamakan Desert. The Fumen oil field is buried at depths of 7,000 to 10,000 meters, where the temperature can soar above 200 degrees Celsius, and the pressure is strong enough to crush steel. At those depths, oil doesn't sit neatly in large open pools like in many Middle Eastern fields. Instead, it's trapped within layers of fractured rocks, scattered across a maze of underground fault zones. These layers are incredibly thin, sometimes only 60 centimeters thick, and the oil is distributed unevenly, almost like fruit growing on twisted branches buried miles below the surface. Finding these pockets of oil is like trying to locate apples buried under an invisible, rocky forest, each one hidden in a different direction and at a different depth. It's a geological puzzle few countries have ever managed to solve. Every meter drilled deeper brings new risks. There are sudden changes in rock hardness, explosive gas pockets, and areas where drilling tools can easily get stuck, or honestly, even melt due to the extreme heat. Traditional drilling methods would fail long before reaching such depths. This is why many experts once believed that extracting oil from this desert was nearly impossible, both technically and economically. But for China, giving up wasn't an option. The challenge became a test of innovation and national determination. So, engineers across China joined forces to develop new technologies, tools and methods that could see through the earth, withstand unbearable pressure, and drill faster and more accurately than ever before. What they created would not only unlock the secrets of the Fumen oil field, but also push China to the forefront of global drilling technology. To conquer the depths of the Taklamakan Desert, Chinese engineers had to do something no one had ever done before: give the Earth a kind of CT scan. This led to the creation of a groundbreaking system called ultra-deep seismic exploration technology. Here's how it works. Imagine the desert floor as a giant solid wall. Engineers place signal generators and receivers in precise grid patterns across thousands of kilometers. They send sound waves deep into the ground, and when these waves bounce back, they carry hidden clues about what lies beneath, like echoes revealing the shape of an unseen world. By analyzing those echoes, engineers can map underground faults, rock layers, and even tiny cavities where oil and gas might be hiding. It's like building a three-dimensional treasure map of what's happening 8 to 10 kilometers below the surface. But mapping alone wasn't enough. The team developed two new technologies to make this process even sharper. Three-dimensional imaging of ultra-deep reservoirs, which lets scientists see detailed structures underground. Fine characterization of fractured and cavernous rocks, helping pinpoint where oil is likely to flow. These innovations improved accuracy dramatically, from about 30 meters of error to just 15 meters, which is honestly remarkable considering the scale and depth involved. With these tools, engineers could now see the underground world in full 360 degrees, making the invisible visible. Next came the challenge of drilling. For that, China developed ultra-deep, fast, and efficient drilling technology. Essentially the key that opens the Earth's deepest vaults. But the journey down is full of surprises. Volcanic rocks, high-pressure water layers, and unstable faults can appear without warning. One mistake could cause an explosion or collapse, ruining months of work. To solve this, engineers created a dynamic seismic profile correction system, a real-time GPS for drilling. It predicts problems ahead, adjusts the drilling path instantly, and keeps operations safe even in unpredictable environments. And to break through rocks harder than concrete, they invented a hybrid drill bit, combining the toughness of diamond bits with the cutting power of roller cone bits. They also built high-precision sensors that survive extreme conditions, 200 degrees Celsius heat and 200 megapascals of pressure, which is about 2,000 times the weight of air at sea level. These breakthroughs transformed deep drilling from a near-impossible mission into a controlled, scientific process. What used to take years could now be done in months, and soon China would put these technologies to the test in record-breaking operations.